Hello guys, we're going to talk about the graphs of three inverse trigonometric functions here today. Now, there are a few things. Okay, we're going to talk about inverse sine, and later on we're going to talk about inverse cos and inverse tangent first. So before you actually start to cover how to draw the proper inverse trig functions properly and effectively, we need to understand about the basic features first. Okay, let's do the inverse sine and sine x function first. Okay, well, a lot of people may be thinking, well, we can cancel it out or something. It's not really. Okay, you must be very careful about this notation here. Okay, what I'm going to do now, remember we're going to swap input and output value, then we can add -1 or just remove the inverse notation. So what I like to do, I'm just swap these two. Okay, I just swap these two. Say sine x moves to the left hand side, and then y moves inside of this one. Then we swap the values, so we can take inverse notation away. So that's where inverse notation is missing here. Okay, so just be careful. If you swap them, you can add inverse, or you can eliminate inverse notation. Okay, so that's the first thing. Now, what do you want to do next? The next step may be a bit dangerous for you. Say, for example, what I like to do, if you say sine, say y equals to, say sine 30, for instance, you may want to say, y equal to 30 degrees. Well, that may be correct, but it does not cover whole or full answers. Okay, technically, well, you may not get any full marks at all. So you may lose a mark from your exam questions. Now, the reason is this one. Sine y equal to sine 30, okay, say sine y, that's just specific value, which is a half. So that question is same as sine y equals to half. So what's y? Yeah, first y value may be, okay, well, is definitely 30 degrees. And then there may be another values, okay? So look at here in the sine graph, we do many frequencies over here. Say that is a half. Okay, goes on here. That equals to 30. There's another values. There are lots of other values as well to make the resultant sine values. Okay, so the 30 is not only the value to make this equation satisfied. That's the one of the things you have to remember here. Okay, so here, so the common mistakes after this step is just y equals x. This is not true. Okay, please be careful. You have lots of other values as well. So like this one. So many answers. Well, in comparing, say, with just a specific number of answers or many answers, how do you recognize? How do you represent them? Well, if you have, say, sine y equals to sine 30 degree or sine y equals to half, and if you have a domain like in between, say, 0 to 360, then you will have one or two answers, or just limited number of answers. Then we're gonna call them as a particular solutions. But there isn't any kind of domains given, then your answer must follow the general solution. Okay, general solution does mean is a unlimited number of solutions. Okay, so therefore we cannot list all of the solutions here. So therefore we have to set a kind of a formula or kind of mathematical expression to represent all of the solutions here. Okay, so what is it? We have to follow the general solution. Okay, now what is the general solution for that over here? For example, sine y equals to sine 30. What are you going to do? Yeah, we have to follow the general solution here. So that is the only one of the particular solution here, or we can call it as principal value. That makes sense, okay? And then that is what we covered already. So if you can't remember how you get this one, please refer the general solution videos. Okay, so that lesson will tell you exactly why this general solution, why this formula is coming from. Okay, so please take your time to go back to the video which explains about the general solution. Then please don't forget to come back to this lesson, then continue. Okay, so that's the general solution of the sine function. Okay, that's the first thing. So when you have, when you are required to draw this graph, you will need to sketch this graph. We'll cover the way how you draw this graph a little later on in this video. Okay, so don't worry about that. But most importantly, you're not going to write y equals x straight away. It's just a straight line. That's one of the biggest mistakes in mathematics. Okay, I don't want that to happen to you. Now, we're going to talk about inverse cos now, guys. So if it's inverse cos, you may make a similar mistake as you did over here. Okay, so again, please don't make it silly. Now, make it cross-swapped over there, okay, cross-swapped, so as we did in the sine functions here. So what's next step? Yeah, of course, you will have to write the answers or the solution in general form. Can you remember the general solution of the cos? Yeah, see, a lot of you may remember, but some of you may not remember. Again, in that case, please go back to the general solution related video and take your time to review them and come back to this video later on, okay, once you get understood, okay? And then, okay, now, what's the general solution of the cos function? 2n pi plus n minus the initial value or the principal value, okay? So that is the way you can make this equation simpler. So if you are asked to draw this inverse function, you will need to sketch this one instead. Okay, so you can't actually sketch this one, right? Now, third step that we need to do is inverse tangents now here. Okay, so inverse tangent, yes, second step is always the same. So swap the input and output value there. Then, okay, it's time to remember about the general solution regarding to the tangent. What is it? This is the general solution for the tan. Again, if you can't remember, please go back to try to search the general solution related videos, and we can work from that. Okay. Now, okay. So if you same story, if you're asked to draw this function, you can sketch this one instead of the horrible looking question. Okay. So these are pretty much what we need to apply for the lessons of throughout this lesson. Okay. Okay, now what I'm going to do here is to start sketching some examples of the inverse trig functions. First of all, inverse sine and sine x. So sine x is the input value of the inverse sine function. Now, first of all, well, it will have the small part of the question, say A, B, C, whatever, but these A, B, C are actually the sequence of your drawing, of your complete drawing. Okay, so kind of steps that you do. So always the first step is to find out the domain, unless it is specified. But it's not specified, yeah, we have to find out. Okay, so what's the domain? Firstly, okay, say that is so kind of few tiered functions over here. Okay, and x here. So the very outer, it has inverse here. So that's a very outer, okay? Very outer. And then little one layer inside, there is a sine function here. So it's just a sine function. And then another internal area, there's an x function here. So they're actually three-tiered function. Now, we're going to start from the very internal first, which is this one. So what is the requirement of being an input value for over the domain of the sine? Well, think about sine graph. What was the sine graph here? Sine graph is everywhere. Okay, so these are the input value, which is domain. So what's the requirement or what's the limitation of the x value? No limitation at all. Any x value can be inside of the sine function. It doesn't really matter. Okay, therefore, what do you want to say? It will be all real x values. Okay, it will be all real x. Does it make sense? And then if it's all real x, then yeah, it does follow any other rules, so it doesn't really matter. Okay, so that's all real x now. say that we sketch the all real x like this one. So all real x, say any x value are allowed to be an input value for the sine function. Right, we're going to have a solid yellow line over there in the x-axis, and then we're going to find the range. Now, we're going to sketch the stuff that we're going to find out the range, then we will have to work out here. Firstly, I'm going to show you something here, guys. Some students don't like this one, but you have to do this, unfortunately. Okay, sorry guys. Okay, x is real value. So sine x, what is the range of sine x, guys? Do you remember range of sine x? Well, sine x everywhere, say top is 1, the bottom border is -1. Therefore, sine x must be in between 1 and -1. Does it make sense? Now, we're going to attach or apply the inverse sine function for 3 of them. So what I'm talking is -1 sine x and 1 like this one. We're going to apply inverse sine for all of them. Say this is what I'm talking to you guys. Okay? So sine inverse like this one. Can you see that? Okay guys. Okay, so that is what we are looking for, which is y. So y is in between. What is the sine inverse 1? Say sine inverse 1. Sine inverse 1. Okay, sine inverse -1, sorry. Okay, how do you do? Well, this negative will get out. So what is sine inverse 1? It is pi on 2. So negative, it will be -pi on 2. So you can say, oh, -pi on 2. That value becomes here. So sine inverse 1 is obviously pi on 2. So therefore, the range of the function is in between -pi on 2 and pi on 2. Does that make sense? Okay. Okay, so that's how you find the range. So please do consider how you specify the range into the graph. How do you do it? Like this one. Okay, you're gonna specify. Well, it looks like express the upper bound or lower bound. Well, that's actually the same thing for the range. Okay, so we've just defined the domain and the range. The third step is to sketch the real graph. Okay, so say the real graph. Do you guys remember how you change the format at the beginning of this lesson? Yes, most of you can remember. Okay, we got to swap them. Okay, we're gonna swap sine x goes here. Okay, sine x goes here and y moves the other side, and then inverse disappeared. Now, sine y equals sine x? I did tell you guys, please do not write y equals to x. This is incorrect. So what do you need to do? What sort of formula do you have to use? Yeah, that will be the general solutions. Okay, so what's the formula for the general solution of the sine function? You got to remember. So that is the solution for the general solution. Just the format of the general solution, guys. Okay. Now, how you handle this number n? Well, if you have the questions like, okay, sketch pi, say plus x, you can just sketch. It's just a specific, or it's a very common linear function or straight line. But there's an n. Okay, so n is an integer, so it can be 0, 1, -1, 2, -2, whatever. It's correspond, okay, to all of the real integers. So what you can do, it is impossible to substitute all of the integers here, but we can just select a few representative or a few important numbers. Well, not important, but few kind of outstanding numbers. Okay, say the outstanding number can be 0, 1, -1, 2, -2, etc. Okay, then we can see the pattern. Then we can complete the whole graph. Okay, so that's what I'm going to do. Okay, let's get started from substituting n equal to 0. Okay, so substitute n equal to 0. What happened? 0, 0. So that's certainly nothing. Okay, well, not nothing. It will be 0, and then 0 power will make it is 1. So what's happening here? That will be just simply x. So the equation of the graph when n equals to 0 is y equals to x. So you got to sketch y equals to x graph. How simple? So y equals x graph will be just a simple straight line. Okay, sketch like that. Just be careful, guys. Do you know? Yeah, do you recognize why there's a dotted line over there? Yes, because of the range. The range must be in between pi on 2 and negative pi on 2. Any part exceeding this range will be ignored. Okay, you have to ignore anything outside of the range. So that's why it is represented as dotted line. Does it make sense? Hopefully, you should make sense, guys. Okay. Eventually, we're gonna chop that out later on. Okay. If you reach the final stage of the sketched graph. Now, what do you want to do? Yeah, we're gonna substitute another value for this. Say, yeah, 1 is a good number. Okay, guys, substitute 1. What do you do? If you start with 1, yeah, we substitute 1 pi, substitute 1, the power is 1. Okay, then pi plus, that makes negative x, so pi minus x. A simple algebra, everyone. Okay, we can sketch now y equals to pi minus x. So how do you sketch y equals to pi minus x? Well, pi represent us, which the y-intercept. So it will be around here. So that will be pi, and minus x is descending graph, which is the 45 degree over there. So it will become like this one. So like this one. Okay. So you can sketch that. Again, the same reason. You're not going to include the part which are not part of the domain. Sorry, range, guys. Okay. So yeah, so it's a quite interesting graph, isn't it? Okay. Next one. What do you want to do? What do you want to do? Yeah, we're going to substitute n equals to negative 1. Okay. As I told you, we're going to start from the very good numbers and extend the numbers and see the pattern of the graph. Well, that's the best way to sketch this sort of general solution based graph. Makes sense, does it? Okay, we're going to substitute negative 1 here. So what's happening here? I substitute negative 1 there. Say negative 1. Okay, well, that one, how do you calculate negative 1 and negative 1? So this negative 1 makes us its reciprocal. So 1 over negative 1, which is negative 1. So that's why it becomes negative 1. Okay, so we can sketch negative 1 graph. How do you do? Easy. Okay, you can sketch the graph quite easily. Okay, perhaps I don't have to explain why you can sketch this graph like this one. This is so basic. Okay, again, if you can't figure out how you can sketch, how you can draw the straight line, please go back to the how to sketch the straight line video. So that will help you very comprehensive understanding. Okay, now what are you going to do? You're going to substitute n equals to 2. Okay, say not many things to do yet, guys, now. Okay, so you probably see some patterns already by some students. So n equals to 2, we're going to substitute 2 and 2. Okay, that makes sense. And 2 pi, and then minus 1 and square, it makes positive x. So you can sketch this one. Can you do this? Can you sketch that? So 2 pi is the y-intercept, is way above there. And then is a positive x, which is a positive gradient over there. Okay? So try like this one. Again, they are not part of the graph. So that's when n equals to 2 now. Next thing will be the last step. Can you guess what the number that you're going to substitute? Yeah, it is negative 2. Okay, substitute. Please do substitute negative 2 into n here. It came out like negative 2 pi plus x. Negative 2 pi is y-intercept is somewhere down there, and positive gradients that come out like this. Can you sketch? Yeah. Okay. So, what's your conclusion of all of them? What's your conclusion, guys? Yeah, it's like a jig-jag graph. So you don't have to substitute 3 and negative 3, 4 and negative 4, etc. They're so tedious. So now, what your conclusion for this case is just coming around there. So that's all you need to sketch. Okay? So that's how you sketch y equals sine inverse and sine x graph. Looks funny, however, it requires lots of prerequisite skills and knowledge for you. Okay? Hope that there's no trouble for you. Jump on to the next question. Okay, same story. Inverse cos and cos x. Okay. All the scenarios will be, to be used for this graph will be pretty much the same as we did in this inverse sine graph. Okay, let's get started. But there are little, minor differences between the functions. Okay, depending on the nature of the individual function. Well, sine inverse, cos inverse are certainly different, but categorized as the same inverse trig function. So there are little differentiations. Okay, that's why you have to be very careful in handling this question. Now, state the domain. Okay, what is the domain? Okay, well, again, we need to look for these x values here. So what sort of x value can go into the cos function? What do you think? Say, to get understanding better, so you can sketch the cos graph. So x value, well, you can substitute any values into the cos function. There's no limitation at all. So therefore, what are you going to say? So any values can go in here. So no limitation. So anything. So you're going to say all real x values for cos x function. Hope you understand this one. Okay. Now, sketch all real x into the graph. How do you do it? We did it around 5 to 10 minutes ago, like this one. Okay, sketch the whole solid x-axis. Okay, that all x values are applicable for the graph. Good. We have a good start. Next one, you're going to find out the range. Okay, so how do you find the range? The range. Okay, again, same thing. So cos x is in between what and what? What's the range of the cos function? Well, I'm not talking about inverse cos. I'm talking about the input value of the inverse cos now. What is the range of the cos x? Can anyone tell? Well, it'll be 1 and minus 1 again, because the cos function, is still in between 1 and -1. So nothing different from sine function, because cos and sine function is just shifting left and right hand side a little bit. Okay, so that's all. So therefore, it doesn't influence to the range, the coverage of the range at all. Okay, so that's what you have to do. Now, that is the value. So cos inverse, any value in between -1 and 1, say that is pretty much all of the domain of the inverse cos. So what do you remember about the range of the inverse cos function? Do you guys remember the graph of the inverse cos? Yeah, that was like this one. Okay, that's inverse cos. You got to remember about the shape. Okay, the very specific shape got to be remembered. Okay, so that value was 1. Okay, which is this value, which is that value as well. And then the leftmost border is -1, which is the left end of the domain. Okay, and then what is the range for that? Okay, so graph is there. So start from here, end it over here. So that is the range of the inverse cos function. What is the top value? It will be pi. Okay, so therefore range of the whole this inverse cos function will be in between 0 to pi, as I stated over there. Does it make sense? Does it? Yeah. Now, okay, we are ready. So what you're going to do now? State or represent the range into the graph. How do you do it? Well, just in between 0 to pi. Okay, just in between 0 to pi. Just write the upper border. Okay, the upper border and specify the lower border. Okay, or bottom border. Okay, we're going to sketch there. Similar story. Okay, we're going to find out the general solution for that, as we did a few times already at this lesson. Okay, swap x and y, swap cos x and just y, and then eliminate the -1 notation because they are no longer an inverse function. Okay, and then, okay, I don't want you to make a silly mistake here. Say x is not y, x is not y. Well, x is y is good, is right, but x is not x equals to y is not the only solution for this equation. What do you do? Yeah, you have to use the general solution, guys. Okay, right. The general solution. One of the things you have to do is, you have to remember about the general solution formula. There's nothing that I can do help you, but you got to remember. Okay, go for it. Okay, so what's the first step in drawing this graph? Yeah, we got to substitute few outstanding values for n. Okay, n is an integer not real values. So n can be 0, 1, -1, 2, and -2, 3, -3, etc. So lots of value. Again, we don't want to substitute numerous n values, but we can substitute few outstanding values, then we can get the pattern of the moving of the graph. Okay, so that's the story. Okay, so what's the first value that in your mind now? N equals to 0. Okay, it's as simple as this. So substitute n equal to 0. Okay, so what's happening? It'll be plus minus x. So you got to sketch y equals to x. You got to sketch y equals to -x. Okay, so one at a time. So here we got to sketch y equals to x, which is the simple straight line, which is a positive gradient. Okay, can anyone answer why these are represented in the dotted line as well as this one? Yeah, can you answer that? Yeah, because they are not part of the range, because they exceed the range. Okay, so covered is the range, so we are not going to include them into the graph. Okay, but we can sketch with the dotted line because we just have a long straight line. Okay, it doesn't really matter as long as you can take them out later. Okay, now what's the next one? Yeah, we can sketch y equals to -x here. Y equals to -x. Yeah, is that y? Sketch that. Same story. The dotted line are not included eventually. Okay, at the end of the whole working. Okay, it looks like a V graph. Okay, so what's next stuff to do? Yeah, we're gonna substitute n equals to 1. Okay, we're gonna say n equals to 1 there. Yeah, do substitute 1, guys. Okay, substitute n equals to 1. So 2 times 1 times pi. So 2 pi plus minus x. Again, same thing. You gotta do one sketch at a time. So y equals 2 pi plus x. Yeah, that's y equals 2 pi. So that equals 2 pi over here. Okay, that will maybe 2 pi, which is y-intercept. And then sketch 2 pi minus x, 2 pi minus x. But there's a negative gradient, so will be over there. Okay, will be over here. What do you want to do? Substitute n equals to -1. So the -1, it came out like -2 pi plus minus an x. Okay, plus minus x. So we can sketch one at a time. Plus, yeah, that's this is a graph for -2 pi plus x, because that will be -2 pi, and then negative gradient the other side. So have you a good guess, guys? What's your guess? Well, you probably have a good guess by everyone, because it does show you obvious pattern. Okay, so final graph will be just this one. Okay, it's same as zigzag, as well as the inverse cos function. Inverse sine function, as we did in the previous question. However, the range makes a bit different. Okay, guys. Okay, so that's the inverse cos function with regarding to the cos x as an input function. Now, next question is regarding to the inverse tangent. Okay, as a tan x function, tan x is an input value of the inverse tan. Exactly the same story, exactly same scenario. Okay, so if you work harder for the previous lessons, okay, of this video, then you shouldn't be having any problem in going through this question. Okay, so for this one, I'm going to the same way, but I like you to do more work than I do. Okay, so let's get started, guys. State the domain. Okay, so let's be careful. As I stated earlier, each function, okay, the sine function, cos function, tan function, tangent function, are having just minor differences between those two, those three. So tan x has its own specification, okay, its own properties in terms of the domain. What's happening? What's happening there? When you see that, the tan, say 90 or 10 pi on 2 equals to, what is that value? What's the exact value, guys? Do you remember? 10, 90, or if you're not familiar with the radian, you can use the degree instead. That's exactly the same output value. So what's the value? They are commonly infinity. What is infinity? In other words, undefined or math error in your calculator, which means these values are not part of the graph. There's no such value corresponding to these values. Therefore, the domain will have some limitation which is different from sine and cos functions. The sine and cos function has no limitation in terms of x values, okay? But this is having some trouble, some exception, okay, some limitation. Makes sense, guys? So, what else? So, we're going to find all limitations of domain. Sine pi on 2 is infinity. So, what else? Say 3 pi on 2 and 5 pi on 2. So, there are few exceptions here. So, these values will produce infinity, okay, which is undefined. Therefore, you got to remove these specific values from the domain. Does that make sense? But all of the values okay, but you need to accept those few values. Well, not few. They're already unlimited exceptions. Okay. So how you represent this in the graph is this one. Okay. So these particular values should be removed because they are producing the unlimited or undefined value, okay, or math error values. Okay, so they are not part of the domain. Okay, now next one is to find out the range. Okay, so we just sketched that. Next one, state the range. Okay, well, every value can go in here, so it's almost approximately everything. Therefore, we got to follow the natural range of the inverse 10. So why the range of the inverse 10 is in between pi on 2 and minus pi on 2? We covered them already, so please refer that video, okay? Now, specify this range into the graph. See how you go. Make sure they are not included, okay? They are not included at all here. So you have to be careful in not including those upper and lower border, okay? Does that make sense? Okay, so how you sketch that? Up and down. And you got to exclude those two particular values up and down. So they are not included in the graph. Now, we got to sketch the graph here. So how do you sketch? Okay, well, we got to find the general solution. Write the general solution first. Okay, swap input and output. We can get it. And then x is not the only solution. You have to use the general solution over here. So what's the general solution of 10? Tangent, which is n pi plus x. Okay, y equals n pi plus x. So we're going to sketch here. So how do you sketch? Substitute n equal to 0, 1, minus 1, 2, minus to see the whole pattern. Okay, this is not the first time for you. We're going to substitute n equal to 0. Substitute n equal to 0. So y equals to just x. Okay, so y equals to just x. Let's sketch that. Make sure they are not included. So these 2 points are not included because not part of the range. And then n equals to 1, substitute 1. So n pi plus x. So n pi plus make sure they're all positive gradients. Okay, it is impossible to have negative gradients because there's no such other coefficient, okay, in front of x. So it's always plus 1 as a gradient. Now pi plus x. So there's a pi. So it's a pi. So plus pi plus x over here. So it will be like that. Okay? So make sure they are not included. Minus 1, same story. Sketch that. Okay? Substitute n equals to 2. Substitute. So sketch 2 pi plus x. Easy. Substitute n equals to negative 2. Yeah, sketch negative 2 pi plus x. Easy. So what's the conclusion of the graph? What's the final answer? Is that just like a shaded, okay? Like a shaded graph. Make sure they are not included over here. Okay, so this is the basically all you need to know about the inverse sine, inverse cos, inverse tan as an input of its regular function. Okay, it's so yeah, I don't think it's very straightforward to sketch for everyone, but this graph will give you better ranking for you because not many people can do this one straight away. But if you can prepare, can practice a lot for those 3 important graphs, yeah, you will get much better results than others. That's what I'm hoping to you. Okay? Okay, we'll see you at the next lesson then.